hustling, 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 hustling. Every day I'm hustling, every day I'm hustling, every day I'm hustling.
Hello ladies and gentlemen, I'm Justus Winn-Howard, and today we're going to be finding data on something that changes over time and deriving an equation of that data as a function of time. Then we're going to find the instantaneous rate of change of that function at any given time, and lastly find any relative minimums and maximums using the first and second derivative test. So with that, let's get started. Alright, so the first step in this process is finding data on something that changes over time. And to do that, we're going to use the price of a Ford Mustang from 1991 to 2011. So that's over a 20-year span. And in order to do that, you first have to find data online. And then once you do that, you can create a spreadsheet and have the years in one column covering the 20 years. And then in the next column, for each of those years, you fill in the price of the car at that time period. And that's what you do to start out your data. And then once you have that data, you can create a graph from it, and then you'll get all these data plots right over here, and you'll see that it's a linear graph with the trend line in the middle. And then you can also set up the spreadsheet to get the equation of this graph as a function. So in this case, our function for this data of the annual price of a Ford Mustang is f of x equals 569.11x minus 1,121,878.11. That equation might not make sense right now, but basically from that equation we can plug in any year, whether it's 10 years from now, which would be 2021, or 100 years from now, which would be 2111, and we could see, according to the historical change in price over time, an estimate of how much the car would be with fluctuation, etc. So that's how we can find data on something and derive an equation of that something as a function of time. So that's the first step to this. Now we can also look at this graph and find out some other things. For instance, if you wanted to find the instantaneous rate of change of this equation at any time, you could simply take the equation right here, and I will come over here and write that bigger. So f of x is equal to 569.11x minus 112. Alright, so to find the slope, all we have to do is simply derive this equation. And since this equation is in a form like this, we can simply use the power rule to do this. So using the power rule, we would simple out that 569.11x derived would simply equal 569.11. And then for this number here, without the variable there, that would simply become 0. So the derivative or slope of this function would be 569.11. So that would be how you find the derivative of this equation. And with that, you can see the slope of this overall graph, and that would be the slope at any time. And lastly, we can use the first and second derivative test to try to find any relative minimums and maximums. Now, for this equation in this case, we can't set 569.11 to 0, which means that there's no variable that we can plug into this equation to make it 0, which means there are no relative minimums and maximums. So what that means is on a graph like this, it can go up to infinity on the right, so it can continue going up here, and it can go down to infinity on the left, so going down there. So that means there are no relative minimums or maximums to find. And now using the second derivative test, technically, since there are no relative minimums and maximums, you wouldn't need to do the second derivative test, because that's simply to find out what the concave is on the minimum and maximum. But if you were to do the second derivative test, if you derive this again, it equals 0, which means the slope or the rate of change never changes. So that means there's a constant change in this graph. But again, you wouldn't need to get to that point using this data because it wouldn't be relevant. And with that, that covers everything I wanted to go over in this video. Well, ladies and gentlemen, that concludes this video. We went over a lot of things in this video, and I hope you understood it all. If not, you can always go back and watch it again, and I hope you eventually understand it. Until next time, I'm Justus Winn-Howard. See you later.